Guys, Mrs. Dan's here. Sorry for the interruption. So I had said that we can enter this into our calculator as is, or we can multiply it through, and I started doing that. So now I have a -3 times x squared minus 4, and when I distribute the -3 through, I get -3x squared plus 12. Really, both of these things are mathematically equivalent. We could take a look at it on our calculator. If I enter in the original expression as it was given in factored form, I type in -3 times x minus 2 times x plus 2. And if I really did simplify it properly, when I enter into y2, the equation that I got, I should get the same values in my table. -3 x squared plus 12. And let's go look at our table of values. And I can see they're identical. Another thing is that luckily enough I'm scrolled to the exact right spot. I could see that my turning point is at 0, 12. So I will copy down this table of values. You know what? I feel like I'm not going to have enough room here. I'll put my table of values over here. -3 to 3. -15, 0, 9, 12. -15, 0, 9, 12. And now it's symmetric. I don't think I'm going to be able to fit 0, -15, but I definitely want to fit my turning point, 0, 12. So I'm going to plan properly. If this is 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I'm going to make my x-axis here. And I'll plot. Remember, it's supposed to be a U-like in shape. I do have a hard time drawing with this pen a bit, so sorry for not being perfect. It says identify the key features. This is a key feature, it's a turning point. Another key feature is the axis of symmetry. These are key features because they're the roots. This root is when x equals 2, while this root is when x equals -2. The y-intercept happens to also be at 12 because the turning point and y-intercept are the same thing. On your test, I probably want to ask you to just label key features. I'd probably be very specific and ask you about certain things so that you didn't leave anything off. If you know that a parabola is symmetric, you should easily be able to do this. They're telling me that the vertex is at 4, -2. So the axis of symmetry goes through there. If the axis of symmetry goes through this point, then the point that they labeled here of 2, 0 has something that matches it on the other side. And 8, 6 has something that matches it on the other side. And 5 points is plenty to draw a parabola. Find the y-intercept. It's here at 0, 6. The y-intercept is a point. If you were at 6, I'd accept it also. The x-intercepts, they're points. One of them is at 2, 0. The other is at 6, 0. If they asked a different question, which is so much related, if they ask for the roots, you can only give the x values. The roots are at 2 and 6. So be careful about what they're asking for. The interval on which the rate of change is always positive, that's where the graph is increasing. So it's here where I'm drawing in blue. That interval is from 4 to infinity. When I ask for the interval where it's positive, they're talking about the x values, or they could be asking about the domain over where it's increasing. And the sign of the leading coefficient. I know it's positive, and if you're unsure why, I want to look back up to this one. Notice this parabola is opening downward. It's because the leading coefficient is negative. Since this parabola is opening upward, its leading coefficient must be positive. Something else that we should know is that if this number is greater than 1, it's going to be narrow. So this is a fairly narrow parabola. If it was a fraction between 0 and 1, the parabola would be wide. So the more narrow it is, the larger the number is. It's greater than 1. Next page. Greg is in a car at the top of a roller coaster ride, and the distance d of the car from the ground as the car descends is determined by that equation, where t is the number of seconds it takes the car to travel down to each point on a ride. How many seconds will it take Greg to reach the ground? Anytime you see about reaching the ground, please remember you're trying to find a 0. Or you're trying to find a solution, or you're trying to find a root. It says solve algebraically. The only algebraic method we know right now is by factoring. There are other algebraic methods, but I didn't teach them to you yet. So if they ask for an algebraic method on your test, the only thing you could do is by factoring. The only other method you know is a graphic method, which is not algebraic, it's graphic. So we have to solve this algebraically. And we want it to hit the ground, so we want the distance to be 0. So in place of a d, I'm going to put a 0. GCF, there's a 16 in common. How many times does 16 go into 144? 144 divided by 16, I did it before, it's 9. And then we look at these parentheses, and they're a difference of 2 squares. 9 is perfect, 3 times 3. T is perfect, t times t. Since it's a difference of 2 squares, one gets a plus and one gets a minus. Then we set each factor equal to 0. Does 16 equal 0? Absolutely not. There really are 3 factors here, but the 16 doesn't equal 0. Maybe 3 minus t equals 0. Maybe 3 plus t equals 0. So we solve. And t can be 3, or t can be negative 3. T is time. In seconds, time can't be negative. This gets rejected. So the time must be 3 for when it hits the ground. So we'll answer that in a sentence. It reaches the ground in 3 seconds. It also asks us to solve it graphically. So we need a table of values. I'll just label this x and y. I was looking for the name of the function. They don't really have a name. I guess I call this a d instead of a y. And they call this a t instead of an x. We go to our graphing calculator and we enter in the 144 minus 16t squared, and, oh, that's not squared. Try that again. 144 minus 16t squared. I was gonna scroll through for the turning point, but it's perfect. So from negative, I can't graph from negative 3 times, so I'm going to start from 0. 0, 1, 2, 3. At 0, it's 144. That makes sense. It started 144 feet high because of that part of the equation. At 1, it's 128. At 2, it's at 80. And at 3, it's at 0, which means it hit the ground, and we knew that already. So I don't have to write down the 4. At 4, it goes below the ground. And yeah, a roller coaster won't do that, unless there's a tunnel underground, but they didn't tell us that. So 0, 1, 44, these are all going by 10s. 10, 20, 30, 44. 1, 128. And 2, 50, 60, 70, 80. I hate this pen. It doesn't always do what I want it to do. 3, 0. This is half of a parabola. The other half is over here, but I can't have negative time. We don't put arrows because it doesn't go into the negatives. Solve graphically, when does it hit the ground? At 3 seconds. So you could do it both algebraically and graphically. What is the average rate at which the roller coaster is dropping between 0 and 2 seconds? So I need 2 points. One point has to have a 0 for the x value. The other point has to have a 2 for the x value. We can use our table. It's 0, 144, and 280. Rate of change is really y2 minus y1 over x2 minus x1. So I will do 80 minus 144 over 2 minus 0. 2 minus 0. 80 minus 144 is negative 64 over 2, which is negative 32. And it makes sense because it says, should say dropping. I notice it says dopping. We're missing an R here. Dropping. The negative represents the drop. So the average rate at which the roller coaster is dropping, it is dropping at a rate of 32 feet per second. Between 0 and 2 seconds.